account. Tonight we're going to talk about right triangles. We're going to talk about right triangle similarity and then trigonometry. And at any point throughout the night, please send me questions, okay? Right triangles are a pretty major topic. We use them a bunch. And let's get started. So we are going to start with right triangle similarity. This tends to be something people struggle with because it's a very small blip in the curriculum, but it always shows up on the Regents. Last year it was like a proof explanation. Some years it's just multiple choice, but we're going to take a look at it and kind of see what's what with this. So we're going to start by looking at this. This is a right triangle, ABD, and it has an altitude that's been drawn in it. And so what winds up happening, remember altitude is causing right angles, right? So I wind up getting a right angle over here, a right angle over here, and then I had this original right angle. And so I wind up with 3 right triangles. And a really cool thing happens here. We wind up with 3 similar triangles. So there's a little one, a medium one, and then the big one. So what I want to do is kind of look at those and analyze, well, what's the deal with them? And then what's the similarity between them? So let's talk about the little triangle first. So I'm going to say ACB. So that would be this triangle. So A is up here, C is over here, B is over there. And so notice this is like the little leg, this is the big leg, and that's the hypotenuse, right? So that's what I'm going to kind of think about. Now let's do the medium triangle. So the medium triangle, if I draw it oriented the same way, I would be kind of like rotating this around, right? This is now the little leg, this is the big leg, and this is the hypotenuse. So my little leg is AC, C is my right angle, and then D is my top. Okay, so again, right angle, right angle. And now let's look at the big triangle. So I'm looking at orienting this the same way, and that's going to take a reflection and a rotation. But little leg is this, A is the right angle, B, and then D would be your top point, because this is the big leg, and that's the hypotenuse. So I see that I have these 3 triangles. I see that now I've oriented them all the same way. And the really cool thing that happens here is they're all similar. So because of that, I can make this similarity statement. And remember, when you make a similarity statement, you always want corresponding points to be in the same place. So I'm going to say A, B, C is similar to triangle. Now A is corresponding with D. So D, A, C, again, I'm going around in the same direction, is similar to triangle D, B, A. Okay, going around in the same direction. All 3 of those are similar. You have right angles, and then you have shared angles with reflexive property. And so this is something that then creates a bunch of proportionality. You can either redraw your triangles like this every time, which would work, or you can remember these proportionality sort of theorems. And at least in my class, when we do this, we do a lot of color coding. So here's the first scenario that we have. If we have, and I'm going to make this line a little bit thicker, an altitude in a right triangle, then the other 2 segments I'm going to look at with it are this one and this one, the 2 pieces of the hypotenuse. If we have a leg, the 2 pieces that we're going to look at are the piece nearest the leg and then the whole length. And those just come from this relationship that we saw right here. The fact that these are similar, so these are just corresponding parts. But these scenarios, remembering these kind of relationships, can really help you, because here's what we know. In each of these scenarios, I can set up a proportion. The one that was its own color is going to repeat. So I'm going to do it on the top of one and the bottom of the other, because that is what's called the geometric mean. It happens in both places. And the other one, we're going to put one here and one there. And then we can cross multiply and go from there. So we're going to do a couple different problems and look at how these are done. if you have questions at any point, please send them, okay? So let's look at this first one. Which proportion would always represent a correct relationship? So what I'm going to start doing is doing some of this color coding, okay? And we'll see which one works. So the first thing that I know is if I knew the altitude, then the other two pieces that I would look at would be this piece right here and that piece right there. So let me try setting up this proportion. So what this proportion would look like would be the one that's its own color will appear twice, Z and Z. And then the other pieces will appear in the opposite spots, so X and Y. So let's see if that's an answer choice. So X over Z and Z over Y. That happens to be answer choice 3. Now the other option that we could use here, and I'm going to do this in 2 other colors, is I could also have done, let's say I did side A, and then I could have said, okay, well the piece closest to that is this, and the whole length is that. And if I had done that, the proportion I could have written was, that's a little large, Mrs. G. A would be the thing that repeats because it's its own color. And then X, and I think that this was C. Right? Yeah, that whole length was C. Again, that would be another one that's true. It's just not an answer choice. And so we can get these relationships this way. But that's what I would always do is look at what you know, try to match it up to an answer choice. Okay, let's look at the next one. The accompanying diagram shows a 24-foot ladder leaning against a building. A street brace extends from the ladder to the point where the building meets the ground. The brace forms a right angle with the ladder. So I know that I've got a right angle, and these are right angles. I see that this is an altitude from the right angle. If the brace is connected to the ladder at a point that is 10 feet from the foot of the ladder, which equation could be used to find the length of X? So I'm going to do some color coding here. First thing I'm going to do is do the altitude its own color. That's what I want to find. And the other 2 pieces should be this piece and that piece. So setting up this proportion, I would have, well, the one that's its own color is the one that repeats. And then what are the other 2 pieces? Well, this one is 10. And since this whole length is 24, this one has to be 14. So that's the equation that I'm looking for. And that is numero uno, number 1. All right. Next one. Again, send questions as you have them. All right, so this tells me that this is a rectangle, which means that's a right angle, and that these are perpendicular. So I know that's an altitude in the right angle. I want to find the length of AS. So here's AS. Let's color code our other 2 pieces. It would be this piece and that piece. So let's set this up. I would have AS as the one that's repeating, and then the other 2 go in the other spot. So AS needs to repeat, and the only one that happens in is answer choice 1. All right, let's try actually solving some problems with this. So I see 7 and 16, and they tell me what is the length of BD. That's my unknown. So I see that that's my altitude. I'm going to color code that. And then these 2 pieces would be this piece and that piece. And I know that this is 7, so this would have to be 9. So I'm going to set up my proportion. X is the one that's going to repeat because it's its own color. And then 7 and 9 go in that other place. So cross multiply, x squared equals 63. Square root both sides. So x is the square root of 63. And now you have 2 options. Let's say you forgot how to simplify. You got nervous, you forgot. Put this into your calculator, and then put each of the answer choices into your calculator and see which one matches. Okay? Now your other option is to say, well, 63 is 9 times 7. And I know the square root of 9. I don't know the square root of 7. Square root of 9 is 3, and that's radical 7. So this would be answer choice 1. Hi if you're still just jumping on. Again, send questions at any time, okay? All right, so let's look at another one. Altitude is drawn. If UT is 12 and RT is 42, meaning this is 30, what value of H would make RST a right triangle? This is another way of asking the same thing. If this is a right triangle, then this proportion holds. So that's my altitude. That's one piece. That's the other. And so when I set this up, the altitude will repeat. This would be 30 and 12. And we're going to do some, I don't know why I did that on my calculator. That's 360. So this would be h squared equals 360. So h is the square root of that, which is the square root of 36 times 10. So this is 6 radical 10. Again, if you weren't sure how to simplify that, put that in your calculator, put your 4 answer choices in your calculator, and just see which one matches. Okay, let's maybe do one more like this, and then we'll go to the leg. So, all right, I really want to do this one. In the right triangle, CD is the altitude. CD is 6. The ratio of AD, that's this little piece, to AB, that's the whole thing, is 1 to 5. Determine and state the length of BD. So here's what I'm going to say. When I say I have a ratio of 1 to 5, that doesn't mean that this piece is 1 long and that piece is 5 long. It really means that this is 1 times some number and this is 5 times some number. So what I need to know is this. If this is one piece, this has to be the other 4. So if that's 1x, this is 4x. And so now I'm going to set this up much the same way. My altitude is 6, so that will be the one that repeats. And then this will be 1x and 4x. So what I get here is 4x squared equals 36, which means x squared equals 9. Square root both sides, that means x equals 3. So I know x is 3. Now, am I done? You know if this was a multiple choice, x equals 3 would be an option. But we're smarter than that, because what I want is I want the length of BD. So I'm going to plug this back in. I know BD is 4x. So BD is 4 times x, which is 12. Okay, so now we're going to move on to some with a leg, and I'm going to give it about 30 seconds for questions, and so I can answer a quick message here, and then I will be right back with you guys. Again, send questions. I'm just answering a couple questions people sent me. We're going to start with legs in about 30 seconds. Okay. Whoops. Flip. All right. So now let's go look at these. And here was the other scenario that we had. When I knew the leg, I would color code that one color. And then the 2 other pieces I would color code would be the piece closest to the leg and then the entire length. Okay? So if AB is 36 and AC is 12, what is the length of AD? So, okay. I want to know the length of AD. That's this little piece here. So let's set this up. I am going to have the one that's its own color repeat, so 12 and 12. And then the other 2, it doesn't matter where they go. So I get 36x equals 144. And 144, I should be able to do this in my head, but I can't. Divided by 36 is 4. So that would be answer choice 4. Same idea, different setup, right? Okay, next one. CD is the altitude. CB is 6. AD is 5. What is the length of BD? That's my unknown. So let's do some color coding. So this is the one that's its own color. And then this is one piece. This is the other. So setting this up, 6 is its own color. So that's going to go there. Okay? Now I'm going to set this up. The piece closest is X. And the whole thing is X plus 5. So I'm going to cross multiply. That gives me 36 equals X times X plus 5. And now here, if you're stuck on this, if this scares you, you have answer choices, right? Plug them in and just see which one works. That totally works, okay? But the other thing we can do is actually solve this algebraically, and I'm going to do that because I know you guys are capable of this. X squared plus 5x. This is quadratic, so I'm going to make it equal 0. So 0 equals x squared plus 5x minus 36. Then I'm going to factor this. So what multiplies to be 36 but adds to be 5. So 36 is 9 and 4. So x plus 9, x minus 4. And then set each one of those equal to 0. So x plus 9 equals 0, x minus 4 equals 0, x equals negative 9, x equals positive 4. So that length can't be negative 9, so it must be positive 4. All right, last one of these, and then we're going to start with trig. So what is the length of AD to the nearest centimeter? All right, let's set up what we can. There's multiple ways to do this one. There's a lot. But what I would look at is, okay, I know that this is 6. And I know I want this. So if I could figure out this whole length, I could figure this out. Well, this is a right triangle. And if I know two sides of a right triangle, I can always figure out the third using Pythagorean Theorem. So I know that that's the hypotenuse. So I'm going to do 6 squared plus 8 squared equals c squared. 6 squared plus 8 squared is 100. Excuse me. So c equals 10. So this whole length is 10. So let's set this up. The one that's its own color repeats, 6 and 6. The other two I will set up in opposite places, doesn't matter where. So I get 10x equals 36. So x equals 3.6. There are other ways to do that. That is the fastest one. Okay, send any questions on those. While you guys are doing that, we're going to do a brief synopsis of SOHCAHTOA and trig. So, the idea with SOHCAHTOA, and it only works in right triangles, it is the ratio of sides. And in any right triangle, the ratio of sides is always going to be the same value, given that the angles are the same, right? Any similar triangles, their sides will have the same ratio, their corresponding sides. So, here's the deal. We use SOHCAHTOA to help us remember. So is short for sine, is opposite over hypotenuse, so S-O-H. Ka is short for cos, is adjacent over hypotenuse, A-H. TOA is short for tangent, is opposite over adjacent of A-H. You always take the sine, cosine, or tangent of an angle, and that angle is represented with the Greek letter theta, which kind of looks like a zero with a belt on, okay? So, these are your ratios. For sine, you're going to use opposite over hypotenuse, okay? If you don't know, so that's this angle. If you're trying to find the angle, but you know the sides, you're going to use the inverse of sine. And when you use your calculator, there's the sine button. See how in blue it says sine to the negative first? That means sine inverse. So you do second sine for that. Okay? We also use the sine and sine inverse buttons on our calculator. For cosine, cosine is adjacent over hypotenuse. And to find the angle, we do cosine inverse of adjacent over hypotenuse. We use the cos and the cos inverse buttons. For tangent, tangent is opposite over adjacent. And we use that theta is the inverse tan of opposite over adjacent to find the angle. So we use tan or tan inverse buttons. Okay? So you're always going to write either sine, cos, or tan of the angle equals that ratio. So let's do a couple of these. So in this diagram, the angle of elevation from a point on the ground to the top of the tree is 34. Angle of elevation, in my classes I always make you guys do this. Angle of elevation is how you look up. So that's this angle right in here, how you look up. So angle of elevation there is 34. If a point is 20 feet from the base of the tree, so here's the base, this is 20 feet. What is the height of the tree, x, to the nearest tenth of a foot? One of the most important things you can do here is check the mode of your calculator. So when you turn on your calculator, it is going to maybe default to radian mode, especially if you are using an older siblings calculator. So I am going to, in mode, it's hard to see, go over to degree and hit enter. Okay, now I know I'm in the right mode because I'm using degree. So let's set this up. So from 34, always start at your theta. This x side is the opposite. This side is the adjacent. And so O and A, OA, is tangent. So I'm going to say tangent of 34 equals the opposite over the adjacent. Now to solve that, I'm going to put this over 1. And I'm going to cross multiply. So x times 1 is x. And then this is 20 times tangent. And sometimes that helps to keep that 34 in parentheses, so you don't try to do 20 times 34. So in on my calculator, I'm going to type in 20 tan 34, just like I wrote it. And I'm going to throw my calculator. I'm going to hit enter, and that comes out to be 13.4901734. So to the nearest tenth of a foot, that is 13.5. Okay, an important fact to remember, and this will definitely show up on your regents. If A plus B equals 90 degrees, so if the angles are complementary, then sine of A equals cos of B. I guarantee that you will see that on your regents, okay? So which of these is true? They tell us angle C is 90. Well, in a triangle, all the angles add up to be 180, which means if this is 90, then A plus B is also going to be 90, right? So these are complementary. So what that means is then that sine A equals cos of B. Done. That's all you need to know. Okay? Next one, which expression is equivalent to sine x when we're between 0 and 90? Well, they're all cosines. So I know that sine of A equals cos of B when A plus B equals 90. So what I know is that x plus whatever the angle is has to be 90. So I'm not going to say that it's x because I don't know that this is 45 and 45. But look at this one. If one is x and the other is 90 minus x, wouldn't those be 90, right? X plus 90 minus x. We call that the complement. Those add up to be 90. So it is 1. All right, number 4. The complement of B is A. What is always true? Complement, sine A equals cos B. Done. Okay, so let's look at another one where we're actually solving. In this diagram, AB is 14 and AC is 9. What is the measure of angle A? So let's just start by setting it up. I want to know this. That's my theta or my x. So from that angle, remember always start at your angle, 9 is the adjacent, 14 is the hypotenuse because it's across from the right angle. Adjacent and hypotenuse tells me to use cos. So cosine of the angle equals the adjacent over the hypotenuse. Now, Dividing here isn't going to help. Cross multiplying here isn't going to help because cos and theta are married. We can't break them up with multiplication or division or any of that. The only thing I can do here is take the inverse operation. The inverse of cos is cosine inverse. So if I take the cos inverse of both sides, what I get, well, cos inverse of cos is just theta, is cos inverse of 9 over 14. And so in my calculator, I'm going to put in second cosine of 9 over 14, which looks like that. Second cosine. I'm going to hit enter, and that comes out to be, because I'm in degree mode, 49.994799912. If, let's say, you were in the wrong mode, you would get a nonsense answer that's not in your answer choices. So if that happens, check your mode, okay? So to the nearest degree, that's 50 degrees. All right, probably about 3 more. Next one, diagram below shows a ramp. What is the angle of elevation formed by the ramp and the ground? So this is the ramp. This is the ground. I want this angle. So let's do the same thing. So I want that angle, start at the angle. This is the opposite, that's the hypotenuse. So from there, I'm going to say sine, because it's O and H, so of theta equals 4.5 over 11.75. Now, cross multiplying won't help me here. Sine and theta are like this. They're BFFs. So I'm going to do the inverse of both sides. Theta equals sine inverse of 4.5 over 11.75. I'm going to type that into my calculator. Second sine of 4.5 over 11.75. Boom. And that comes out to be 22.5183, blah, 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 blah. So 22.51831413. Now it says to the nearest degree. And on the regions, you need to make sure that you're rounding to the correct place. So this would be 23 degrees. All right. Yep, we got 2 or 3 more. Okay, next one. A carpenter leans his ladder against a house, a window 30 feet from the bottom or from the ground. As shown in the diagram below, the ladder makes a 7-degree angle. Determine and state the length of the ladder. That's this. So, start at your angle, 70. From there, this is the opposite. That's the hypotenuse. So I know that this is going to be sine. So sine of 70 equals the opposite over the hypotenuse. Now, cross multiplying will help me here because x is just chilling by itself. So put that over 1. 30 equals x sine 70. To get x alone, since I'm doing multiplication, I'm going to divide both sides by sine of 70. And these will cancel out. So I get x equals 30 divided by sine of 70. Now I'm just going to put that into my calculator. 30 divided by sine of 70. Again, seeing just what I'm typing into my calculator. Oh, guys, sorry, that's hard to read. And that comes out to be 31.925333317. So, to the nearest foot, what would that be? That would be 32 feet. Okay, so last two, and these are ones where we wind up with multiple triangles in one. And often here, it's going to be helpful for us to use law of sine. You can do them without law of sine, but law of sine usually will make your life easier. So I'm going to start with let's do this one. All right, as the diagram shows below, a ship is headed directly towards a lighthouse that's 125 feet above sea level. At the first sighting, the angle of elevation from the ship to the light was 7. A short time later, the angle is 16. Determine and state how far the ship traveled from A to D. So I want that. So remember when we talked about these, we always did the same thing. Number 1, find all your missing angles. Number 2, find the shared side, either using right triangle trig or law of sine. And then find whatever you need. So let's start with the angles. In this little triangle over here, that's 90, that's 16. They all need to add up to be 180. So this would be 64. Because together those need to add up to be 180. So 74, sorry. There we go. Good. All right, so now this is 16. I see that these are a linear pair. So I'm going to do 180 minus 16, which is 164. And I know that little one's 7 over there. So 164 plus 7 is 171. So this top one up here would need to be 19. So now I've got all of my missing angles. So now I have these two triangles. I've got one over here that I'm going to call the green triangle. Very creative. And one over here that I'm going to call the blue triangle. Okay? And what side is shared between them? Well, this side right here goes through them both. So I'm going to call that Y. That's going to be my shared side. Okay? So I'm going to use law of sine here, just as a review. You can use SOHCAHTOA. That's fine. So here's what I'm going to say. I'm going to say, okay, Y is across from the 90-degree angle. So I'm going to say sine of 90 over Y equals, I know the 125, and that's across from the 16. So sine of 16 over 125. So now let's cross multiply. Sine of 90 times 125 equals Y times sine of 16. I want to get Y alone, so I'm going to divide both sides by sine of 16. And then I'm going to type this into my calculator. So 125 sine of 90 divided by sine of 16. And that gives me that Y equals 453.4944098. So this is my shared side, okay? That's this side right here. And I'm just going to copy and paste that. Notice what I'm not doing here. I am not rounding that because we never want to round on any intermediate steps. We don't want to round till the end. Now we're going to use that to find x. So let's look at this triangle. I want x. X is across from, and I know this is a little hard to see, but x is across from the 19-degree angle. So I'm going to do sine of 19 over x equals, and now I need to look at, well, what is the side that I know there? I know y, and that's across from 7. So sine of 7 over this y value. And in your calculator, just go up and select that value, right? You do not need to retype it all, but you do need to use the whole thing. So now we're going to cross multiply. So x times sine of 7 equals 453.4944098 times sine of 19. Divide both sides by sine of 7. And here's what I'm going to put in my calculator. I'm going to put that last answer times sine 19. Make sure you close your parentheses after. Divided by sine of 7. And so that comes out to be 1211.488746. And they want it to the nearest foot. So this would be 1,211 feet. Now, I believe that I have a couple videos just about these that I will link in the down bar below, okay? We did a lot of these where we had the double trig, and all you want to do is make sure you find all missing angles, find the shared side, and go from there. Okay, so I'm going to call it a night. Thank you for those of you that hung out with me. I'm going to stick around for questions for a few minutes, and then we are going to move on. So our next live stream will be Tuesday, and keep looking for text tips throughout the weekend. I will be here for a few minutes, but I hope you guys have a great day, a great weekend, And I'll see you later. Thanks for watching.